Yeah, we discussed about the last class regarding our tungsten cathode preheated type. So, in tungsten cathode preheated type, the electrons are produced by thermionic emission. Lower starting operating voltage are adequate, and a transient voltage of 300 to 600 volt applied by the starter initiate the arc stream. The coating material decay in each starting of the lamp. The constant impact of electrons of the cathode also dislodges some of the emitting material. Finally, so little of the material is left that is not possible to emit an electron, and the lamp becomes dead. This type of lamp is unsuitable for frequent starting. So the fluorescent lamp produces flickers or stroboscopic effect. Since 50 cycles supply, they are extinguished 100 times a second. Single lamp cannot be operated without flicker. Flicker correction can be applied to pair of lamp. So radio interference is another effect produced by fluorescent lamp and has to be removed by a suitable filter circuit. The advantages of fluorescent lamp is that it is efficiency and life under normal condition are almost three times those for filament lamps. The quantity of light obtained is superior and glare is minimum, and the fluorescent light source casts soft shadows. However, the initial cost of the lamp and filling is higher than the incandescent lamp. Starter of automatic starting switches are of two types. One is thermal types, another one is glow discharge types. So what is this thermal type and glow discharge type? We will discuss. So thermal type starter has a heater coil which heats a bimetallic switch. The heater coil remains energized to keep the bimetallic switch open throughout the operation. It therefore consumes a small amount of power, and figure below shows the circuit diagram of fluorescent lamp started by a thermal starter. When the supply is switched on, the contacts of the bimetallic switch are closed, and the current passes through the electrodes and heats them up. But after an interval of few seconds, the heater coil is heat up the bimetallic strip, and the bimetallic switch contacts open. This starts a high voltage transient across the electrode due to the presence of the choke or blast in the circuit. An arc is struck between and the electrode due to the high voltage transient. The identical circuit. So the identical circuit showing the use of glow starter can also be used as shown. Because almost we use glow type switch starter. Glow starter is enclosed in a glass tube bulb filled with a neon or argon. One of the electrode is bimetallic strip. You can see the previous diagram. You can see here. Yeah, this is your glow type starter. You can see the diagram here. It is written single 222 to 40 volt and 4 to 65 watt glow starter with a condenser. This is the glow type starters. So, and we generally use in everywhere in fluorescent lamp, we generally use a glow type switch starter only. So because the glow type starter have some advantages over the another type starter, because here we can find here the glow type, because nowadays we use without starter. Nowadays we have a electronic choke, so there is no need of starter. So this is about a glow type starter. Yeah, so you can see the glow type starter is enclosed with a glass ball will filled with a neon and argon. One of the electrode is a bimetallic strip. It is a bimetallic strip. Okay, so this is a, you can see the diagram of a condenser of a radio interference suspension and bimetallic switch, and another is heater coil. So you can identify this diagram. Okay, and here you can see the electrode, and this is a starter, and this is a starter, and this is choke or blast, and it is a radio interference suspension conduction glow type switch. So this is a glow switch. You can come to the point 2. Here you can get is 2. Here 1 2, this is a 1 and this is a 2, and glow switch. 1 is a radio interference suspension condenser and 2 is a glow switch. Here, but here it is a 1 is condenser of a radio interference suspension, 2 is your bimetallic switch, you can see, and 3 is a heater coil. This is the general difference. Okay, so next come to when normal voltage is applied to the lamp, a glow discharge takes place across the glow switch, and a small current will flow through the electrode. The bimetallic strip expand. That bimetallic strip which is present here, you can see this is a bimetallic strip inside the present starter. Inside the starter, bimetallic strip is present. The bimetallic strip expand due to the heating of a current in the glow discharge. The expansion of bimetallic strip causes the electrode touch each other, and the electrode get preheated due to flow of an appreciable amount of current. The meanwhile the bimetal is cool, the glow switch open, and resultant high voltage transient start the arc discharge through the tube. This is the important thing. Okay, what is this important thing? That here this is a glow switch opens and resultant high voltage transient start the arc discharge through the tube. So you can consider is a we can use glow type structures now everywhere. So when a normal voltage is applied to the lamp, a glow discharge takes place. Okay, takes place across the glow switch, and a small current flow through the electrode. The bimetallic strip expand due to the heating effect of the current in the glow discharge. Okay, the expansion of a bimetallic strip causes the electrode touch each other, and electrode get preheated due to the flow of an appreciable amount of current. Meanwhile the bimetallic cool, the glow switch open, and the resultant high voltage transient start the arc discharge through the tube. So this is about your glow type starter. And another we will discuss, that is a gas discharge lamp. So we know that we have a different types of lamp, like a incandescent lamp, like we are using incandescent lamp incandescent lamp, we are using a tungsten as a filament. So because why we use a tungsten in filament in case of incandescent lamp? Because the tungsten have a high melting point and having a low temperature coefficient, and we can withstand any vibration. Mechanical strength is high in case of tungsten filament. So that's why we prefer in incandescent lamp. If anybody will ask you why we prefer tungsten filament in an incandescent lamp, so you can explain like that, because it have a high melting point and it have a withstand any vibration and low temperature coefficient and high resistivity. Okay, this is the point of the tungsten. Because tungsten is a high resistivity material. We know that tungsten is a high resistive material, and it is used in different like our incandescent lamp, like our bulb. It is used in bulb power. So that is called as a incandescent lamp. So what are this gas discharge lamp? So the basic principle of gases discharge lamp shown in figure. The gases are normally poor conductor at atmospheric and high pressure. When application of suitable voltage is known as the ignition voltage across the two electrodes. As a result, in a discharge through the gas, which is accompanied by electromagnetic radiation, the wavelength of this radiation depends upon the gas, its pressure, and the metal vapor used in lamp. Once the ionization has commenced in the gas, it has a tendency to increase. It has a tendency to increase continuously, accompanied by a fall in the circuit resistance. In order to limit the current to a safe value, a choke or blast, we can say it is a choke. Generally, choke. What is this choke? Actually, we know that the choke is made up of copper. We use generally copper choke, and we are using copper choke because copper is an inductor choke. It is a coil, it is an inductor based choke. Okay, so choke or blast is made. The choke perform a dual function of providing ignition of voltage initially and limiting the current. Since due to use of choke, the power factor becomes poor, that is 0.3 to 0.4. Therefore, in order to improve the power factor of the gases discharge lamp use of a condenser, the color of the light obtained depends upon the nature of the gas or vapor used. So this is a gas discharge lamp. This is the just lead in wire and electrodes are there, gas and metal vapor, gas or fuse. This gas discharge lamp. The production of light by this lamp is based on the phenomenon of excitation and ionization in a gas or vapor. We shall now briefly discuss the phenomenon with a reference of the structure of an atom. An atom has a positive nucleus and one or more electrons revolving around it in certain fixed orbit. In certain solids and gases, here are what are known as a free electron, which can escape from the influence of the nucleus of one atom and go over another atom. There are thus a number of electrons which are mobile in nature. If the potential difference is applied to electrode placed in a gas having a large number of free electrons, these electrons will be attracted to the positive electrode, and the velocity acquired by the electron will be depends upon potential gradient. During its motion towards the positive electron, an electron will strike other atoms, and one or more of the following result may be produced. So these are the gas discharge lamp, and this is the total overview of your chapter 4 illumination. And so here important question is that here what do you mean by sodium vapor lamp and sodium vapor lamp, mercury vapor lamp? Another one is your neon lamp, another one is your fluorescent lamps. 4 long questions are there, and we discussed already about the polar curve and types of lighting: direct lighting, indirect lighting, semi-direct lighting, general lighting. This is also a long questions, and up to this you will get your semester examination of all the type of questions, which is the types of lighting scheme. Another polar curve is important, is a long question, and Lambert quotient law, and what is about the law of inverse squares. This is also important long questions. So these are the different types of long questions you will get in your semester examinations. Okay, so now I want to stop. Okay.